Hello everyone, today we will be solving search a 2D matrix, right? So we are given a matrix and we have to find the target. If the target is present inside this matrix, we have to return true, or else we have to return false. So let's see what the question tells us more about this matrix. Each row is sorted in non-decreasing order, which means like the elements in each row are sorted in some order, like non-decreasing order, like 1, 3, 5, 7, and the first integer of each row is greater than the last integer of previous one. Like this 10, the first element of this row is greater than this 7, the last or the greatest element in the previous row. Okay, so let's see, and we have to solve this question in big O of log m into n time complexity, right? So this is a fairly simple question if done using binary search. Let's see why we particularly chose binary search. Why particularly binary search? Because we can see the rows are in order, right? It is in non-decreasing order, as well as like we can see like each column has some order, it is sorted in non-decreasing, as well as rows, even here we can see, right? Hence we saw some order, sorted order, hence we are applying binary search. This is one of a big deciding factor here. So let's try and code this thing. Okay, so it will be rows and columns. Rows would be the length of the matrix and column would be the length of each row. Right, and now we need a topmost pointer, a pointer that will be pointing towards 1, so it will be 1, 0, and another pointer bottom which will be pointing towards 23. The first binary search that we are going to apply is to be applied on the rows to find which row has the target. Okay, so we are just trying to find which row, like we are not traversing in columns right now, we just want to find out. We apply the binary search on the rows. So top would be 0, then bottom would be rows minus 1. Now while top is less than equal to bottom, we will traverse until this condition is valid, and we'll find the midpoint, a mid pointer which will point towards some top plus y2 value, right? Now we can write it as mid, but it's better, and for our convenience purpose only we will write it as row. Okay, so if the target is greater than matrix row and minus 1, we are writing minus 1 here because if the target is greater than this, we know that the target is greater than 7, we will directly shift to the like another row, right? We will shift to this row. If we know that the value or the target we have is greater than 20, we will shift to this row. Okay, here let's see 13. Okay, so in this example 13 is greater than 7, the last element of this row, so we'll automatically move to the second row here. So our answer should lie somewhere in this row, so we'll shift the top pointer towards row plus 1 if the target is less than matrix row 0. Like if we have some target like 3 and we are somewhere here on this row, and we want to find this target 3. So 3 is smaller than this first element, no? So we automatically move to the first row. Similarly, we're going to write this as bottom is equals to row minus 1. Else, if we actually find the row where the answer lies, like we actually find the row, the 10, we have found the row, so we'll break through this loop. Right now we have to check if our property, like if top is still less than bottom. If the top and bottom pointers have crisscrossed each other, we do not have the element in the matrix. So we will write and put a check about that. If top is less than equal, if not top is less than equal to bottom, we want to return false. Right, and again we will calculate the row because we have some value of top and bottom which is the most appropriate. That's why we broke. Right, so we'll write as top plus bottom by 2, and we will again assign 2 pointers, left and right. Left will point towards 0 and column will right will point towards column minus 1, like first pointer, left pointer here, and the right pointer on the last element of this row. Now while low is equals to right, we are going to find our midpoint. Let's write it as m, left plus right minus left by 2. Now this is, I have written this totally out of habit. We are using Python, so it doesn't matter if we write it like this or if we write it like this, it won't be causing any problem. But in other languages, and specifically if top and bottom have huge values, it can cause integer overflow, right? But in this question it doesn't matter, we can totally write it like this as well here only. But it is good to it is a good habit to have if we write it like this. So some places I have written like this, and in some places I have written like this. Now if target is greater than matrix row m, we'll write L is equals to m plus 1. We'll converge towards the right because the target is greater than the midpoint, right? L if target is smaller than matrix row, then we will shift our right pointer and converge towards left, and else we have found our answer and will return true. And if the entire loop is over and we still didn't find, or this is not returned, or anything of this is not returned, it still means that we do not have any answer, or the target does not exist in the matrix. Now let's talk about the time complexity. Since we see that our answer space getting reduced, like it was first n and then it got reduced by n by 2 and then further reduced by n by 4, we can safely say that it should be big O of m, right? Now log base 2m, because now why do we write as base 2? Because we are dividing our search area by 2 every time. If we were dividing it by 3, we would have used base 3, but here we are using 2. Now m is the number of this rows we have, and again we do this, like again we first applied the binary search, and again we are applying the binary search again on the columns. So it would be log base 2n, right? Now whenever we have this thing, we can simplify and write it like big of log m plus big of log n, and this can be safely written as log m into n. Now this is exactly what we want as mentioned in the question, right? So we have successfully done this, and space complexity would be big of 1 because we are not using any external data structure here to save our data at any point. We are just using simple variables left, right, top and bottom. Let's see if our code works. Yes, the test cases got accepted. Now let's try and submit this. Yes, congratulations everyone, we have successfully solved the question. I hope you liked the video. If you have any query, please comment down below and tell us how you like, and if you have some critical views, also write it down in the comment box and tell us how we can improve our video. Thank you.